Welcome, Calculus AB. This is 2 for the chain rule. The essential question is, what is the relation between composite functions and the chain rule? Let's begin. So you've seen derivatives like this on the left before. We know how to find derivatives. Like this is 2x and this is cosine of x and so on. But you haven't seen them like this. You don't know how to derive these. It's like sine of 6x. You can do sine of x, but how do you do 6x? And that's what we're talking about today. We have to use the chain rule to solve these type of equations. So what is the chain rule? Well, we use this when we have a function within a function. This is called composite functions here. So for example, this y equals 3x squared plus 2 to the fifth. This is like the composite form of a function y equals u to the fifth and like u equals 3x plus 2, basically combining those into one function. So how do we find the derivative using the chain rule? And there's two different ways and some notations you'll see for the chain rule. I want to demonstrate it both ways. I tend to use this one more, but I saw this in the book. We're going to try it out. So dy dx, and that's our usual notation for the derivative, we can break this down into dy du times du dx. So these are our two functions here. So if I had y equals u to the fifth, then I could say dy du, that's the derivative of y, and use the variable input in there. So dy du, that's going to be 5u to the fourth power. Now, derivative of u equals 3x plus 2, so du dx, that means the function u, and x is with respect to x, is going to be 3. So, plugging both of those in, we can solve our equation as dy du times du dx. So, dy dx is going to be 5u to the fourth times 3. And that u we can substitute in, so that's 15 u to the fourth, and we can substitute in 3x plus 2 to the u, so we can write that as 15 times 3x plus 2. All right, and there's our answer, or to the fourth power. Now, let's solve this other with the chain rule. So if the derivative, this is using composite functions, f of g of x. We can write that as the derivative of f of g of x times derivative of g of x. So the outside derivative times the inside derivative. So the way this is going to look like, our g of x is actually what is going to be inside 3x plus 2. So derivative of the outside is going to be f prime of, so our derivative is 5 times 3x plus 2 to the fourth, and then times the derivative of the inside, so times 3. And I can rewrite that as 15 times 3x plus 2 to the fourth power, that 3 times 5. So both ways get the same answer. One way to say that is the derivative of the outside times the derivative of the inside. I tend to use this more. So I just think of it that way. And other notations you might see, and I've seen pop up in the book, it's y prime equals f prime of u times u prime. So derivative of the outside function times the inside function. Different notations mean the same thing. So let's decompose these functions. To understand that, you have to understand what function's inside the other function. If this is y f of g of x, what function is inside? Well, my inside function here, for the first one, is going to be the x plus 1. So u equals x plus 1. And the function of the outside, this is like 1 over that function. So y equals, or f of u equals 1 over, I don't say y. I want to say, yeah, y equals 1 over u. So that u is the x plus 1. I'm decomposing that. Right here, the inside function is 2x. So u equals 2x, and your y equals sine of u. Over on this one, your function is actually everything inside the square root. So u equals 3x squared minus x plus 1, and your y equals the square root of u. And that last one right there, this is kind of, you see this notation here, it's kind of confusing. Let's rewrite that as tangent of x squared. The inside is actually your tangent function. So u equals tangent of x, and y equals u squared. You're squaring your inside. So let's use the chain rule for this example. I want to find dy dx for y equals x squared plus 1 cubed. So my inside here is going to be this x squared plus 1. I'm going to use that chain rule. I'm going to find the derivative of the outside. So y prime, or dy dx, is going to be, using the power rule, this 3 times x squared plus 1 squared. So derivative of the outside, now times the derivative of the inside, which is going to be times 2x. And to clean that up a little bit, I'm going to rewrite this as 6x times the quantity x squared plus 1 squared. And that's my answer. So let's do another example. I want to find the derivative of this one. My inside is the 3x minus 2x squared. So my f prime of x is going to be 3 times 3x minus 2x squared, and times the derivative of the inside will be 3 minus 4x. And let's try to clean this up a little bit here. So I'm going to rewrite this as, 3 times 3 minus 4x times 3x minus 2x squared, all that squared. We'll leave it like this. If we wanted to, we could distribute this and get 9 minus 12x all times this x squared. We're done. We're good. Next problem. So find all points in the graph of f of x equals the cube root of x squared minus 1 squared, for which f prime of x equals 0, and those for which it does not exist. All right, so I have to find f prime of x first, and then we're just going to be plugging things in. So f prime of x, again, you're inside here, so I'm going to rewrite that as x squared minus 1. I'm going to write it with exponential form, rational exponents to the 2/3 power. So my inside is going to be the x squared minus 1, and my outside is whatever to the 2/3 power. So using the product rule here, or using the chain rule, I'm going to go 2/3 times subtract 1 from this exponent, so 2/3 times x squared minus 1 to the negative 1/3 power. And then it's going to be multiplied by the derivative of the inside, so multiplied by 2x. Clean this up, and I don't like negative exponents, so I get 2 times 2x, so 4x over 3. And then moving that to the bottom will be x squared minus 1 to the 1/3 power. And I like this. So there's my derivative here. That's my f prime of x. But so I want to figure out when f prime of x equals 0. So I want to figure out when 0 equals 4x over 3 times x squared minus 1 to the 1/3 power. So when is that going to equal 0? That's going to equal 0 when your numerator equals 0, and that's going to be when x equals 0. And the denominator becomes some number. Now, when this is the f prime of x equals 0. That's that part. Now, when we'll do the does not exist part. So that's when this function does not exist, and that's when you divide by 0. That's going to happen whenever your x is the plus or minus 1, because when you plug that in, you're going to have 3 times 0 to the 1/3 power. So can't divide by 0. So that's your answer for does not exist. All right, last one. So I want to differentiate this function. And you see a quotient here, but I'm going to rewrite this as negative 7 times 2t minus 3 to the negative 2nd power. And we're going to use our chain rule here. This is the inside. 2t minus 3 is inside. So following those rules, my g prime of t is going to be negative 7 times negative 2, so positive 14 times 2t minus 3 to the negative 3rd power, subtract 1, and times the derivative of the inside is 2. Cleaning that up, I'm going to get 28 times 2t minus 3 to the negative 3rd power. And I don't like negative power, so I'm going to write this as 28 over 2t minus 3 to the positive 3rd power. And that's a good enough answer. We're done.